Welcome to lesson 3.6. Today we're going to talk multiplying matrices. There is no new vocab for this section. So the first thing we need to know about multiplying matrices, in order to do that, the number of columns in the first matrix must be equal to the number of rows in the second one. Pardon my little mix up there. You cannot flip the order of the matrices to make this part true. The first matrix has to stay the first one and the second one has to stay the second. If they are not equal, then you can't multiply them together. The resulting matrix will have the dimensions of the same number of rows as the first and the same number of columns as the second. And we'll take a look at what that is here on the next slide. So if you take a look at this on the top here, we've got two matrices, A and B, and we want to multiply them together. So the first thing we have to do is we have to look at these two numbers, the columns of the first and the rows of the second. They have to be the same. And if they are, the new dimensions are going to be the other two numbers in each one. So if R is the same in both, then our new matrix turns into an M by T matrix. So if we take a look at this first one here, we've got a 3 by 4 matrix times a 4 by 2. First thing we need to do, make sure those are the same. They are the same. So my new matrix is going to be a 3 by 2, because the 3 and the 2. For the second one here, we've got a 5 by 3 and a 5 by 4. We take a look here. These two numbers are not the same, so we can't multiply them together. Go ahead and pause the video and find the dimensions of the last two if they exist before hitting play and seeing how you did. So for the one in green, you'll notice that the two numbers that we need to be the same are the same. They're both 6. So our new dimensions are going to be a 4 by 2 matrix, because that's what the outside two numbers are, 4 and 2. For the one in yellow, you'll notice that the two numbers we need to be the same are not. One's a 2 and one's a 3, so we cannot multiply them together. So how we multiply matrices together. So each element in a row of the first matrix is multiplied by each element in the column in the second matrix in the order that they appear. So the first value in the row is multiplied by the first value in the column, second by second, third by third, and so on and so forth until you get all of the numbers used. And then we add up all those totals and put that in the spot labeled by the row and column we just multiplied together. So if we were multiplying all the elements in row 2 by all of the elements in column 3, then the sum of those products will go into the new matrix in the spot row 2, column 3. So if we've got these two matrices together, if I take row 1 times column 1, so I'd do A times E and B times G and add them together, and they would go in row 1, column 1, which is right here. Then I would take row 1 times column 2, so A times F plus B times H, and that would go in row 1, column 2. Then I can move down to row 2, column 1, so CE and DG, and that goes in row 2, column 1. And finally, row 2, column 2 would go in row 2, column 2 of my new one, so CF plus DH. So it kind of looks like that, and that's how we're going to be doing it. So here's our first example. We've got these two matrices we're going to multiply together. Okay, so again, we take the first row times the first column. So I'm going to take 6 times negative 5, and I'm going to add to that negative 3 times 3. And that's going to go in the first row, first column spot. I'm going to do row 1 times column 2, so I'll have 6 times negative 4. And I'm going to add to that negative 3 times 3. Row 2, column 1, negative 10 times negative 5, and negative 2 times 3. And then row 2, column 2, negative 10 times negative 4, and negative 2 times 3. So if we solve each one of these, 6 times negative 5 is negative 30. Negative 3 times 3 is negative 9. We add those two together and we would get negative 39. For the next one, 6 times negative 4 is negative 24. Negative 3 times 3 is negative 9. If we add those together, we get negative 33. Negative 10 times negative 5 is 50. Negative 2 times 3 is negative 6, so 50 plus a negative 6 gives me 44. And finally, negative 10 times negative 4 is 40. Negative 2 times 3 is negative 6. 40 plus a negative 6 gives me 34. So here is my resulting matrix. Here's a new one. Go ahead and pause the video and solve this one on your own, and then hit play and see how you did. Go ahead and check your work, but you should have gotten in the matrix 64, negative 50, negative 18, and 13. Now again, we just use 2x2 matrices to show this, but it works for any of them as long as the number of columns in the first is equal to the number of rows in the second. Okay, so make sure that you have both of those, and then you might just be adding more numbers together for each one, but it's still the same process and done the exact same way. The properties of matrix multiplication are similar to the normal properties of regular multiplication. We do have the associative property, but we have a matrix and scalar as well, but they are essentially the same. We can either multiply the matrices in any order we want to, or we can multiply the scalar any way we want to, assuming that we can multiply the matrices together. That's very important. We can do left distributive property, so if I've got C times A plus B, notice how I have C times A and C times B. We also have right distributive property. So if C is on the end, then it becomes A times C and B times C. So again, remember, order matters. We cannot switch them just so that we can multiply them. If they can't multiply in the order that they're in, we cannot do the operations.